In the next two lessons we're going to look at ionic bonds. In this lesson we're going to look at how ionic bonds are formed, and in the next lesson we're going to look at the properties and characteristics of ionic compounds. So an ionic bond is formed when an atom either gains or loses electrons in order to gain a stable electronic configuration. Now, as a result of this, either positive or negative ions are formed, and these are held together by strong electrostatic forces. So an ionic bond is always formed between different elements, never between the same element. So typically this is a metal and a non-metal. So let's just take as an example the ionic bond formed between sodium and chlorine. Okay, so we've got sodium here and chlorine, and so the electron distribution of sodium is 2.8.1, and we'll do the cross diagram for sodium. So we'll have 2 electrons in the first shell, and then 8 in the second shell, and then in the outer shell we've got 1 electron. So what sodium wants to do is it really wants to get rid of this electron in order to get a stable configuration. Now in the case of chlorine, well, the electron distribution for chlorine is 2.8.7. It's in group 7. So its dot diagram will be 2 in the inner shell, 8 in the second shell, that's filled, and in the outer shell we're going to have 7 electrons. Okay, so chlorine wants to get this outer shell filled. It desperately wants to gain an electron in order to obtain its stable electron configuration. So it will readily grab hold of this outer electron from the sodium, okay, to form that stable configuration. Now this is quite an aggressive reaction. The sodium readily reacts with chlorine, producing this bright yellow flame, and of course sodium chloride will be formed as a result. So as a result of this interchange in electrons, we've now got a sodium plus ion. The sodium has lost that outer electron, and that's going to form an ionic bond with the chlorine minus ion, because this has now gained that extra electron from the sodium atom. Okay, so the electron distribution of the sodium ion is 2.8, and the chlorine is now 2.8.8. They've both got stable configurations, and this will now form the repeating unit in the ionic structure. So we can now go and have a look at a slightly more complex arrangement. So for example, we'll take the ionic bond between sodium and oxygen. Okay, let's move over this way. Okay, again, so we've got sodium, Na, and oxygen, again with the electron configuration 2.8.1. Let's quickly fill in the cross diagram for sodium with the extra electron in the outer shell, and then for oxygen, well, that's 2.6. So let's just fill in the dot diagram for oxygen, 2 in the inner shell, and then in the outer shell oxygen has 6 electrons. So unlike chlorine, oxygen wants to acquire 2 extra electrons in order to complete the outer shell and have a stable electron configuration. And to do that, it's going to react with 2 sodium atoms. So one of its electrons it's going to acquire from this sodium atom, okay, and the other electron it's going to acquire from this sodium atom. So the new arrangement is going to look like this. Oxygen has now acquired 2 electrons to form a stable configuration, so it has an electron distribution of 2.8, and as a result it has a charge of 2 minus, and it has formed ionic bonds with 2 sodium ions, each of which have lost an electron, having a configuration of 2.8 and 2.8, and so have acquired each a positive charge, Na plus, Na plus. Okay, so each oxygen ion joins on to two sodium ions. And we can see straight away that the formula for sodium oxide is therefore Na2O. And so we can derive the formula of any ionic compound by considering the interchanges of electrons that take place when that compound is formed. So in the case of sodium chloride, each chlorine ion joins on with one sodium ion, so its formula will be NaCl. Whereas in the case of sodium oxide, each oxygen atom has to join to two sodium atoms in order to achieve a stable configuration, and so its formula will be Na2O.